So in your lab kit, you have something like this. It has, it's a Ziploc bag. You have a block to build your motor on. You have magnet coil. This stuff is expensive. Please don't mess this up, okay? I mean, we probably have some extra, but it's expensive. And if you want to order it yourself, you have to get a whole coil of it, and it adds up. It's copper wire. You have instructions on how to build it, detailed instructions. You're given a bunch of nails and a magnet. Mine has a magnet in it. You might have gotten a compass in yours, in your kit. Mine has a magnet in it. So you get a bunch of nails, okay? Because you're going to build it with nails, the wire, and the board. And you're going to get something that kind of looks like if you just build a basic one based on the instruction, you'll get something that looks like this. In fact, let me connect my camera. I have another camera. The only thing is I have to disconnect my microphone. So my sound quality is going to be lower now. So this is the motor you'll build. Let me change the views. I got too many cameras. So the motor you'll build will look just like this. Okay? Let me hide the name. And you'd be surprised, you can get these to run at 2 volts. But because you guys are on campus, I actually loosened up your goals. So if you look on the last page of your lab, let me change views again. Look on the last page of your lab. This is a 40-point lab. So if your motor runs on 3 volts or less, that's basically the 2 batteries we gave you, then you get 30 points. The last 10 points are you answering the questions on this document. So you do have to turn in the answer to these questions. Okay? So there's 5 questions, each one's worth 2 points. They're pretty straightforward questions. So your video that you create should basically show you and the motor. And of course the motor, you got to show me the power to the motor too. And the armature and the magnet that you build have to be connected in series, not parallel. Those are the main requirements. So you're given the rules on the last page. The armature must consist of no less than 2 2.5-inch nails or a rod or dowel that's no less than 1/4 inch in diameter. You are allowed to use bearings if you want. And you need to use the same enamel gauge that was provided. And the armature and the electromagnet must be connected in series. And almost everybody can get this to work. I mean, it's one thing to get it to work. In fact, a lot of people will get it to run at 3 volts or less. So just to show you again the motor, let me switch views again. Here's our motor when I showed you in class. Now, because I have this camera, you can actually see the commutator. See how it's split? See how the ring is split here? Okay. That's what allows the direction of the current to flip when the armature flips by 180 degrees. So when I turn this motor on, oh, I put this on backwards, sorry. Okay. When I turn the motor on, it'll run. Really fast. So this is running on 5 volts. Okay, this one's running on 5 volts. So what are the keys in building this motor so that it runs on 3 volts or less? So let me show you the armature again. Let's see the armature. Here's the armature that was built by the students. So one of the keys is to make the moment of inertia as low as possible. Okay? Make the moment of inertia of this thing as low as possible so that it rotates very easily. If you just wrap wire around the nails so that you just get just a big mess of wires, your motor is not going to work very well. You want to wrap it tightly. You want to wrap it so the moment of inertia is minimized. Symmetry is important. You want this to be as symmetric as possible. Okay? If you can make this part very symmetric, if you can wind this very symmetrically, then you'll have a motor that runs on 3 volts or less. Now, when you wrap this wire, you're going to probably have to make 2 layers. Now be careful when you make the second layer, the current has to go in the same direction, because if you have 2 layers where the current goes in the opposite direction, guess what happens?
Working against itself.
Yeah, you cancel out you cancel everything out. Nothing's going to work. So that's important. Not only is it true for this, but it's also true for the electromagnet that you build. So this part, this U-shaped part, is the electromagnet. Okay, with the wire wrapped around it, that creates the magnetic field. The nails have iron in them, so it'll get magnetized. The nails help create a larger magnetic field. Okay, and I think you guys were given a compass, if I remember, so you can test with the compass if you're actually getting a magnetic field. Okay. There are ways to test them if you have trouble. So putting this together is actually not hard. Making it work is the engineering part. Okay, not only making first thing is to make it work. The second thing is to make it work under 3 volts. So building it doesn't take a lot of time. You're gonna need a hammer. Okay. And like I said, there's some of you folks who want to go beyond what's asked in here. That's fine. As long as you abide by the rules, that's okay. I actually had somebody machine one. He got it to run under a volt. But it's critical that this thing is wired or wrapped properly. Okay. The other issue is the commutator. So this one's really scratched up. I don't know if you can see the commutator on here. The contacts. So the problem with this is having consistent contacts. So this one student used stiff wires for the contacts. Okay, this one's double over, but these are the contacts, the brushes. Okay, so you need to make sure that when you build this motor that you have consistent contacts. Look at this one. This is very consistent. Okay. If you want to use stiff wire or whatever, I mean, use whatever kind of wire you want to make good contact. In fact, this one person found a little bit of a copper sheet and used it. If you look at the instructions, they just have you use a little bit of the magnet wire to make your commutator. Okay, however you want to do it. Although the sheet is better, we don't provide the sheet, but if you want to use the sheet, you're going to have to get it yourself. You have to go to Home Depot or Lowe's to get it. Okay. So I'm just giving you tips as to how to make this thing work better. The contacts is the big thing. If you don't have consistent contact, you're going to require much larger voltage to run it. Okay. I know that some of you folks do have a power supply. If you want to test it with a power supply, because then you can vary the voltage. If you put too much voltage on this thing, the wire will get hot, and you're going to melt the enamel coating, and that's going to short everything. If you need more than 9 volts to run this, I would check to make sure your contacts are okay. I would check to make sure that you're actually getting a current through your motor. So you actually have to measure currents. The current is going to be significant. We're talking, like 5, 6, 7 amps. It's not going to be a small current. And so if you're using 4 batteries or 5 batteries, you're going to have a significant current in your motor. You folks have questions on this? I'm gonna copy from last semester the discussion board on the electric motor for because you're gonna ask me a lot of questions. Some are gonna be repeated. What do I do? It's not working. All right. So there's several things you're learning from this. You're learning how to troubleshoot, which is an important skill. I don't care what field you're in. Even if you're in computer science, if you're a programmer and you write code, you have to learn how to troubleshoot code. Because if you write code, it's not going to work on the first try. Okay, if you're an engineer, you build something, it ain't going to work on the first try. If you're a physicist, you build stuff, it ain't going to work on the first try. Okay, and you learn from those failures. So no matter what your field is in this course, no matter what your chosen field is, you're going to learn how to. You need to know how to troubleshoot. Whether it's something you build, some code you wrote, or some kind of chemistry experiment, it doesn't matter. This teaches you good troubleshooting skills. What do I do? Okay. Questions? I used to give the class 2 weeks to do this lab, but then I figured, okay, I'll give you guys to the 25th. No questions or concerns? If you wait till the last minute on this one, you're gonna be in trouble because you need to be able to test it. Right? Test it and modify it as needed. And troubleshoot. And the troubleshooting problems are usually little things or little subtle details that cause your motor not to work. But you wouldn't have to take apart your wire unless you wrap the wire twice so that in 2 layers so that the current goes in the opposite direction in each layer. That would be bad. But I have a lot of ways to test them. The only bad part is I'm not there with you to help you because usually in the lab I have more tools at my disposal to test your motor. There's one thing we can measure. We haven't talked about the concept yet, is inductance. I can measure the inductance of your motor. And if it's like 0, that means I can tell your wire's not wrapped right. Okay, but we don't have a way to measure inductance unless you folks have a multimeter that can measure inductance. Questions, concerns? You guys okay? You guys out there?
Yeah, sorry.
Okay. All right.
I'm trying to build it right now.
Okay. Yeah, and like I said, it's not very hard to build. So, so when you make the video, put your name on the motor. I want to see your name on the motor. And I want to see you. Okay. I want to be able to see the motor, how you power it, so I can tell how it's wired. And the video shouldn't be that long. This should be one of your shorter videos. You know, like, it shouldn't be more than 30 seconds. So the file will be small, so you can just upload the movie file, or you don't need to put this on YouTube unless you want to. Okay. You can make a longer video, but I'm just going to look at what I'm going to be looking for is, does it work? And at what voltage does it run at? Okay. Yeah, do you folks have any questions about my little motor I have here? About how it's built? We talked about this about a week ago. Works on the idea of torque. Okay. You got to think about when you want the torque to be maximized, etc. And you'll see this device again, because I'm going to use it as a generator later on in the semester, or in a week, I guess. Actually, maybe Friday I'll use it as a generator. So no more questions, concerns. I did grade your Ohm's Law lab. I mean, most people did fine. There wasn't a lot, because we had to skip the last part, there wasn't a lot to the lab. But most people did fine. You know, so I created a code so I can grade faster on the Canvas. And so I emailed you folks the code, grading code. So like, you know, 1 means sig figs. So if I put a number 1, comma 1, it means 1 sig fig. You made a sig fig error, this should have been 1 sig fig. If I put a 7 on there, something with a graphing error. And at the time, I didn't have units on my grading code, so I wrote units down if you were missing units. But since yesterday, I wrote down 6 A's unit. You're missing units. Oh no, I'm sorry. It wasn't units. It was something else. Show your work. You should always show your work. At least a sample calculation. So if you make a mistake, maybe I can give you partial credit.
Hey, Professor.
Yeah.
I do have a question about the lab, this current one, the motor lab. So when we're doing because we need to wire the armature and the electromagnet, right?
Yes.
So how should we kind of split up the wire we have? Like, should we do half and half or like 2/3?
I would do about half and half, and I think that's what the instructions.
Is it?
Let me see.
It says 400 turns.
So I guess what I would do is maybe wrap about 400 turns.
Each one, or just do the electromagnet first?
I would do the armature first.
Do the armature first?
Yeah.
Okay. And just do 2 layers, so, back and forth.
Yes, you want to be around 400.
Okay.
Because the magnet doesn't have to be wrapped very nicely. Well, you want it to be wrapped nicely so you get a nice feel, but I would just definitely do the armature first, because that one's important. So I would do that first, and then the magnet. Because the armature, you have to be careful with it and how you wrap it. The magnet, not as careful, but still you want to wrap it fairly nicely. And some folks are very good at wrapping a wire around.
Oh, and do we don't want the wire to touch the nails, or does it not really matter?
I'm not sure what you mean. Oh, you mean the...
Like on the armature, sorry.
Well, you're probably gonna what a lot of people do is they use electrical tape around to keep the nails together. It might be a good idea not to make them touch, just in case, well,
My ends are exposed, is what I'm saying. The ends of the nail.
oh, that's fine. Because the wire's coated. The only thing you have to worry about is if you run too much current through your armature, you melt the enamel coating. Then you have to worry about it. But then you also have to worry about the turns of wire next to it too. Because it's coated, you really don't have to worry about it. Is that okay?
Yeah, that's good.
Okay. Yeah, part of it using the coated one as opposed something with something that has a thick rubber over it. It makes everything lighter, and it allows you to make an armature that's not huge. It actually bends more easily too because it's stiff wire. Oh yeah, don't forget when you make the electrical connections. And Tyler provided sandpaper. You have to sand the ends off, right? The wire's coated, so you have to actually use sandpaper to sand the ends off to make your connections. Anything else? So next week, I'm going to have you do a lab. It'll be the shortest lab of the semester. It'll be a 1-week lab. You're going to build. I'm sorry, not build, but we're going to talk about the oscilloscope because the last 2 labs of the semester are going to require you to use an oscilloscope. So you have to learn how to use it first. So basically, you have to go create a video showing me how to use it. It's much shorter than the multimeter quiz. So there should be a pretty easy lab. And did you guys notice the last lab report for the semester? Have you looked on Canvas recently?
I haven't looked at it.
Okay, let me show you the last lab. Hold on a second. Let me change. What's wrong with? That's hard to see. The last one's called Return Lab Kits. So that's your last report. Return your lab kit, you get 20 points. Okay? You got to return your lab kit by December 11th. That's a 20-point lab. So Tyler will okay it, and then I'll give you 20 points. So, do you guys have questions on the web assignment then? If you guys don't have any other questions on this lab.
I have a question on number 6, part B.
Homework 6 or 7? Oh, number 6, you said.
Number 6, yeah.
Okay. Let me. Okay, you can see it. I'll open up to another window. Okay, let me change the window. Okay, I opened up the wrong one, sorry.
I think my issue is I can't like input the answer. Like I tried to practice another version and I wouldn't still
You
get the
could
correct
put it.
answer. For part B.
So does the equation editor pop up in your case?
It does, but like when I saw the correct answer in the practice another version, there was like an E in it, but all I had was just numbers.
I think it's the scientific notation.
I don't know.
I had a question on that one too, because I was just off by a power of 10 and I'm not seeing where I was.
I'm getting part A, it's just part B that's nothing.
Yeah, same here.
Okay, let me take a look at that real quick. My notes. Yeah, there's an E in there, which is strange. It's an exponential.
Yeah, I think it's just saying whatever times 10 to the negative 2, but I got the same answer, but 10 to the negative 3.
Okay. And you use QB cross B, right?
Yeah. Yes.
And it's moving at 150 megameters per second, so it's 1.5 times 10 to the 8th.
Yeah, I mean, I have 150 times 10 to the 6, but yeah, same thing.
Okay. I'm just troubleshooting.
No, yeah, totally. I've been over it like 3 times. I can't figure out where the 10 went.
Let me work it through here on the board using my numbers. Let's see what I get. Okay, let me change views. Okay, so we have a long wire carrying current 12 amps. To the left. Okay, so it's along the x-axis. So let me change this. And then we have another wire carrying the current 60 amps to the right.
I know you're about to get to it, but is the logic for which direction the force goes, is that the same as the way the current flows in the wire for the direction the charge is going? Like if they're going in the same direction, it would go in. they would repel each other, and if they're going opposite directions, they set it backwards. I don't know if that makes sense.
You're talking about the magnetic field to the two wires?
Well, so the charge is moving to the right in between them, right?
Yeah.
So if it's going in the same direction as the current, then the force would be pulling them together, except that it's a negative charge, so it's the opposite.
Yeah. What I would do, I would find the total magnetic field. So I would use this equation. I would do that. So I find the total magnetic field. I need to draw my picture right here. This doesn't belong here. The other wire is carrying current like this.
I get it, right?
Okay. But I mean, you did it this way, or you found the. How did
Well, I did the math, and I think I did it right, except for, I mean, obviously I didn't, but I'm just trying to, like, intuitively, the way the force goes, just so I can check my negative signs and that kind of stuff.
Yeah. So if you the way you did it, then you're saying this: you have a current going this way, and a negative charge going this way, right?
Well, right. If that's the case, then wouldn't the charge...
And that current's in that direction, right?
Right.
Okay. So then they would repel, and so this would go.
Okay.
down.
Yeah, I just want to make sure it was the same. Okay, yeah, so you just think of it like a current. So it is exactly... Okay.
Yeah. Well, it just seems like there's a factor. You're getting a factor of 10 off.
Yeah, it's really bugging. I've got... I don't know. I can't see where I messed up.
This is z equals 0. Okay, I guess it was like this. I had it okay. And this was 60 amps, right? And then you were somewhere in between. So I would first find the total field at this point. Okay, so this is 0.100 meters, and this was point. Is that right?
Yeah.
Okay, so the field into this guy is going to be. Right here, the field comes out of the bore, so this is positive, right? The other one's going to be negative.
Wait, I thought they're both in the same direction, the magnetic field.
They didn't say one goes to the right, one goes. Oh, they're in the same direction.
Are they both in the negative k hat? Or yeah, I think they're both in the negative k hat. The bottom one's also in the negative k hat.
Okay, maybe you're right. Okay, and then we're going to use QB cross B. I forgot the V hat. Let me calculate what that is, okay? This factor ends up being 2 times 10 minus 7, so. Okay, so that's what I got from that magnetic field. Alright. But what I want to do is calculate this. Look okay so far? Oh, it's 2 microcool. I thought it was electrons. Sorry.
Yeah.
That makes me happier actually, because I was worried about the size of the answer. Okay. Let me calculate this. I got something of the same order, so
Yeah, I just got it too. So I don't know what I did.
what happened?
I don't know.
You got it to work?
Yeah, I just got it to work with that. So I must have just dropped something.
So the answer is okay then. And I don't know, this should be. Let me do it one more time because I rounded off something. Yeah, that's fine. So I got it to work out. I didn't do the cross product, but are we okay then? Go ahead. 2 people said they couldn't get the right answer.
I got it.
Okay,
I don't know what happened, but I got it.
that's strange. Okay. All right, good. We got it to work out. Other questions?
Yeah, I have a question on number 5.
Okay, so what is your question about it?
So, if the forces on the 2 straight parts of the wire or of the loop will be in the same direction. But is it that the force on the curved part is that just 0 because it's
They're circular. Yeah, and they're going to carry current in opposite directions, right?
right? So they're going to cancel out.
Yeah.
Okay, so I must have just made it algebra errors. And
Other questions? And you know, and by saying they cancel out, I'm just looking at from intuition that the forces will be equal but opposite on the curved parts. The calculation would probably take a little. The field's uniform over that loop, so you can use the problem I did the other day in class for the semicircular loop if you want to calculate it. But they should be equal but opposite for the 2 semicircles.
For this question 5, I thought that the magnetic field of the I1 is going to be parallel to the semicircle, so the force is going to be 0. Is that like a right way to think about this?
Oh,
Because if we apply the right-hand rule on the I1...
Yeah, you're right. You are correct.
Okay.
But even if it didn't, it would cancel out though, right? I mean...
Yeah.
Yeah. Anything else on the homework? All right, didn't change the view. Let me look at the assignment.
I've only solved 7 questions. I don't know.
Okay, that's fine. It's early in the week, but I'm glad you got started. I'm looking at the ones that are going to be. This is going to be a little more challenging. 16. But most of them are. I mean, they shouldn't be too bad.
yeah, so far it's pretty straightforward.
Yeah. A lot of times it's easy to make a silly error on these, like I do. I can make a lot of silly errors on problems, but I think the last one should be the hard one. The other ones, you know, they should be okay. Because I've pretty much gone, based on my lecture, I mean, I've gone through some version of these problems, or I said something related to these problems in in class. Right, you know, for example, for this one, I discussed something regarding this problem. Okay. And it shouldn't be that hard. You'll have to use the right-hand rule to solve this one. This is Ampere's law. No, this is easy Ampere's law. We did this problem in class. This is just calculating flux. We actually did a problem like this in class, but it was in the previous chapter. These are flux problems. This is one of those other ones where I talked about how to calculate the magnetic field. So it's not that bad. And I did something like this in class, but usually students have trouble with this. So this is a good one to make sure you understand how to do. This is a rail gun. This is not that bad. Yeah, this is last one that I think is the hardest one. So I think this should be okay for you. It might take a little while to get it done, but it should be an okay assignment. Of course, I have office hours 3 times this week, and then when I teach my 210R class, I create a YouTube video and I put it on YouTube. So if you subscribe to the DC Physics California YouTube channel, you'll be able to find it there. Okay. I'm not always going to remember to email the link. That's why I made the videos public view, and I give you the name of the channel so you can go look at it. Are we okay so far?
S corrections, whole thing loaded, like the whole PDF, or do you just want the problems that we fixed?
Yeah, basically the problems that you fix. I mean, you can do it on the, because I put the exam file there. You can just do it on that exam file. It's actually easier for me if you put it on the exam file. The new one. Right, I just created a new exam file. Then I can compare the old one and the new one. Did I answer your question? Or? So Daniel, you're muted, so I don't know if I answered your question.
Oh no, I was just telling my son to leave.
Oh, okay. But yeah, I mean, you just use the a fresh new copy of the exam right on it.
Okay, yeah, I just printed the 2 that I missed, and I'll just, so it's all clean.
Yeah, that's fine. So my effort right now is to catch up on grading, so it might take me a little bit to get through them. I graded your lab 3. I didn't grade the lab 3 for the other class, and I want to grade the worksheet. I want to get those right away because of the next exam. So I'll do those first, and then I'll come back to it. And so I'm hoping those should be easy to grade because you have much longer period of time to go through this problem instead of the hour and a half or 2 hours to do the exam. So.
Also, the Build Savoir worksheet, does that do this Friday?
What did I say? No, I didn't have it due on Friday. I thought I had it due Monday. Like I didn't even put it.
I don't think it has a due date on it.
I'm sorry? It doesn't have a due date. Yeah, I got to remember what I said last Friday. I have to look at it. I thought I had it due on Monday. So just turn it on Monday. I'll put the due dates on Canvas. And the Biot-Savart one of them is not that hard. Actually, one of them is really essentially a problem I did in class. The other one is a little bit harder because you have to set up the geometry. And then the integral, do the integral on Wolfram. unless you're really good at doing integration. Okay. The other one you can just do on Wolfram. Because the second problem, the integration is very difficult. Any other questions? We're all okay?
I think so. The test is next Friday.
The test is next year. What day is that? The 6th? As long as I get through everything on Friday, yes. The one thing that's a pain about the Friday class is that if I postpone an exam, I have to postpone everything a week. And I'm trying to stay about a week ahead because of the Thanksgiving break that's coming up. So yeah, right now we're on schedule for November 6th for exam 3. And I think for you guys, for the 4th exam, I have that one actually delayed a bit because of that Friday that we have off. If I remember, your 4th exam is way... Let me check here. No class. And your 4th exam doesn't come until after until December 4th, just because of that the holiday break that we have. And then your 5th exam comes a week later, but the 5th exam is a short exam. It's just not one chapter. Okay, so your 4th exam will be a month later, which is a good break for you. Your 4th exam will be, you'll have actually a lot of extra time to study for it. Okay, so if you don't have any more questions, excuse me, I guess I'm done. So we'll see you on Friday, or I'll hear from you during my office hours. All right. Oh, you didn't have any other questions on anything else then? Okay, take care then.
Thank you.
Yeah.